Alright, so in this video we are going to go over one of the recommended chapters to study for the Access Certificate exam. Let's start with Video Compression, Chapter 7. So this is the textbook that you can get for free from them. I'll put a link in the description. It said Chapter 7 Video Compression, but it looks like maybe 6 is Video Compression. Alright, so let's just kind of skim through this and try and get the information we need for the test here. So video compression is reducing and removing redundant video data to be able to compress the bit rate. So there's different types. There's image compression, JPEG compression, and then there's video compression like the H.264, H.265 compression algorithms. Use interframe, and these use interframe prediction to reduce video data sent over a series of frames. Access video products allow users to set the group of pictures GOP length, which determines how many P frames should be sent before another I frame is sent. Lowering the frequency of I frames, a longer group of pictures, the bitrate will be reduced. That makes sense. But the video quality may drop if there's congestion on the network due to network packets being lost. Access uses 3 video compression standards, H.264, H.265, and then motion JPEG. H.265 and 264 are the latest, most efficient. So this is the most widely adopted standard for video compression, H.264. You may have seen it a lot using like video VLC media player. Alright, ZipStream for these compression algorithms. Access ZipStream technology is a radically more efficient video encoder implementation. Further lowers bandwidth and storage requirements by an average of 50% or more. It's in no way a replacement, but an improvement that is 100% standard compliant. ZipStream is a collection of different algorithms that reduce bandwidth. There's a dynamic region of interest algorithm, a dynamic frames per second algorithm, a dynamic group of pictures algorithm. So different parameters for the ZipStream, you can set it to be off, disabled, the lowest value 10, no visible effect in most scenes, going all the way up to 50 extreme, visible effect in most scenes, less noise, lower level of detail in regions of lower interest. Alright, motion JPEG as a compression. Since with Motion JPEG there's no dependency between the frames, that makes it more robust. It's an unlicensed standard, broad compatibility, but again not as good at compression compared to H.264 because it is a series of still complete images, leading to higher bitrate, low compression ratio. For video products with a resolution above 1080p, Motion JPEG may not be usable since the images become too big to transfer over a 100 megabit network in full FPS. Upgrading to gigabit network will only move the bottleneck to the image processing steps in the camera. If JPEG images are required, the system frame rate must be reduced accordingly. Alright, so let's talk about the different bit rates Axis can have. There's average, variable, and maximum bit rates. With ABR average bit rate, a specified amount of storage is used over a given period of time. The video stream is assigned a certain amount of storage, and the average bit rate controller in the camera will adapt the video to try and fit that. With variable bit rate, the image quality is maintained regardless, but this means that bandwidth will increase, of course, when there's more activity in the video. When maximum bitrate is used, you're setting a maximum limit for the camera. When there's video with a lot of activity and it goes over that maximum bitrate level, you're going to see a lower quality in the video image. Axis Site Designer can be used to estimate bit rates for various types of scenes. It's probably an important piece to know for the test. Axis Site Designer can be used to estimate bit rates for various types of scenes. Alright, so that's the video compression. I'll stop the recording here.